Forces, nature's tug of war. When you ride a bike, your foot pushes against the pedal. The push makes the wheels of the bike move. Okay, we've probably mostly all done that. You push down on the pedals and the bike moves forward. But you probably didn't think about why. Alright, when you drop something, like this football player is dropping this football, he fumbled, it's pulled to the ground by gravity. You drop anything, it's pulled to the ground by gravity. But you probably don't think much about gravity being a force that's pulling on something, do you? Forces are pushes or pulls. The definition of a force is a push or a pull in a particular direction. That's all it is. We're not talking about Star Wars here, we're talking about real life. So forces are pushes or pulls in a particular direction. Forces affect motion. Okay, there are 6 ways that forces affect motion. Just like this guy is putting a force on these baskets and making them move. Let's talk about what the 6 ways are that forces can affect motion. Number 1, forces can make objects start moving. Alright, you see this race car here. When you step on the gas in the car, the engine puts a force on these wheels that makes the car start moving. So that's the first thing that forces do. They affect motion by making objects start moving. Okay, forces can make objects move faster. Let's say this jet plane is flying at a constant speed, but if the pilot gives the engines more throttle, then they will push harder on the plane and they will make it move faster than it was before. Okay, so that's acceleration. So forces can make objects move faster. Alright, the third way that forces affect motion is they can make objects move slower. Okay, if you step on the brake of a car, the brakes put a force on the wheels, but instead of making them speed up, it makes them slow down. So forces make objects move slower as well. They can. Alright, the fourth way that forces can affect motion is that forces can make objects stop moving. Alright, when this car crashed into this wall put a huge force onto the car, and that made it almost immediately stop moving because it puts such a huge force. Okay, so forces, and you know, if you're in a car and you step on the brakes, not only can they slow it down, but they can make it stop. So forces can make objects stop moving. Alright, forces can make objects change direction. Okay, this soccer player, when this ball is coming toward him, it's going in one direction, but then when he kicks it, it'll be going in another direction. His kick is a force put on that ball, and it'll make it change direction. Alright, and then the 6th way that forces can affect motion, forces can make objects change shape. Okay, this aluminum can was a particular shape, but this person put a force on it with their hand, and that made it change shape. Okay, so there's your 6 ways that forces can affect motion. Alright, so let's talk about some of the facts about forces. Forces are measured in units called newtons, alright, and they are named after Sir Isaac Newton, and he is a famous scientist who basically discovered gravity, or he was the first person to say, hey, there's this force that pulls things down to Earth called gravity. So force, the measurement of the amount of force is in newtons, and this is what you measure force with. It's called a spring scale, and so you hook it up to an object to see how much it pulls or pushes, and it's measured in newtons. Okay, another fact, forces usually act in pairs. Okay, a person sitting down in a chair, well, their body puts a force down on the chair. Gravity's pulling them down, but the chair is also pushing up on them because they're not moving anywhere. So there's 2 forces pushing on this person. Okay, And then this is just a little picture to show you that this person is trying to hold a tractor going one way, an elephant going the other way. They're both putting a force on this person. Okay, they usually act in pairs. Forces act in a particular direction. Okay, you remember that from the definition of a force. All right, and these little arrows show different forces that are acting on a car. Okay, like when the car's moving forward, it's got a driving force pushing it forward, but the air, you ever stick your hand out the window of a car when it's going, you can feel the air push your hand back. The air resistance is pushing backwards on the car. The weight of the car is pulling down on it, but the reaction force from the ground is pushing up on the car. And then, of course, there's always, when something's moving, there's always friction, and that's moving the opposite way of the way that the car is going. So forces can act, they always act in a particular direction. Another fact about forces is that they usually cannot be seen, but their effects can be seen. Okay, like this magnet. You can't see the magnetic force pulling on an object, but you certainly can see it when an object is attracted to a magnet. In this airplane, you can't see the forces pushing up on the wings, but it certainly makes the plane fly and keeps it in the air. All right, so you can't see them, but you can see their effects. Multiple forces. More than one force can act on an object at a time. The forces can push or pull in any direction. So what happens to the object when the forces act depends on two things. It depends, one, on how strong the forces are, and two, the direction of the forces. All right. So, like this person sitting in the chair, the weight is pulling this person down, but the chair is pushing back up. All right. So there's two forces acting on this person just by sitting there doing nothing. All right. So now we're going to talk about when forces act on an object, what happens to them. When more than one force acts on an object, the forces combine to form a net force. Net means total. Okay, the combination of all the forces acting on the object is the net force. Okay, so like these three people pushing this car, maybe this car is broken down. Okay, so when these three people push on it, they each put a force on this car. The total amount of force that's being put on this car is equal to the amount of force of each of these people added together. That's their net force. All right. Forces that work together may be opposite forces. All right. So these people all pushing together were not opposite. They were pushing in the same direction. But when you have a tug of war, you have forces acting on the rope in opposite directions. This team over here is pulling this way. This team on this side is pulling the opposite direction. So it could be that the forces acting are opposite. In fact, it's quite often that they are. All right, two or more forces, opposite forces, are balanced forces if their effects cancel each other and do not cause an object's motion. Okay? So if two forces of equal strength act on an object in opposite directions, the forces will cancel, resulting in a net force of 0 and no movement. Okay, so if you have a tug of war and the two teams are exactly balanced, the rope doesn't move anywhere. Okay, that's because one team is pulling one way, the other team is pulling the opposite way, and the forces cancel each other out, so it doesn't move. You know, some of these other slides we have seen a person sitting in a chair, you know, like this one. Okay, this person doesn't move because the two forces acting on this person are opposite direction, but they're equal. So when you sit in a chair, your weight is pulling you down, but the chair is pushing back with an equal and opposite force, so you don't move anywhere. Okay? All right. If the effects of the forces don't cancel each other out, if one force is stronger than the others, the forces are unbalanced forces. Unbalanced forces cause a change in motion or speed or direction. Okay, so here's an example of unbalanced forces. The ball is flying toward the batter from the pitcher, okay, with a certain amount of force that the pitcher put on the ball, made it fly, made it go through the air, but then when the batter hits it, there's going to be a greater force from this bat than there was from the ball coming forward, and that's going to change the direction of the ball and make it fly in the opposite direction. So this is an example of an unbalanced force, and I bet you can think of lots of times where you put a force on something and made it move or made it change direction, and that was an unbalanced force. Okay. When two forces act in the same direction on an object, the net force is equal to the sum of the two forces. Okay, we kind of already talked about that with these folks pushing that car. We said the amount of force on the car is adding up these three people's forces. Well, this is exactly what this is saying here. Okay, so if these two people are pushing on this chest of drawers to move it, okay, one person is pushing with a 200 Newton force, another person is pushing with only a 100 Newton force, but together they are putting a 300 Newton force on this chest of drawers because 200 plus 100 is 300. Okay, so forces add up if they're in the same direction. Right. When two unequal forces act in opposite directions on an object, then the net force is the difference of the two forces. Okay. So, these two dogs are pulling on a toy. If the little dog pulls with 10 newtons, and the big dog pulls the opposite direction with 20 newtons, then they're going to be moving toward the right because the big dog has a stronger force. I'm sorry, not 20, but 12. Okay, so they're going to be moving toward the right, toward this dog, because this dog is pulling harder. All right? But you subtract to figure out how much the force is. Okay. You take the larger one, 12 minus 10, that's 2 newtons. So because this dog is pulling with 10 newtons, it reduces the amount of force that this one is to only 2 newtons. So they're only pulling this direction with 2 newtons. Okay? It's just a tiny bit of really simple math. All right. Let's talk about showing forces on your assignment. Okay. A force can be shown with a vector. All right, this little arrow right here is a vector. The dot shows where the force begins, and the length of the arrow shows the amount of force. Okay, and it says here's 5 newtons. Now, why is it 5 newtons? Well, you count how many little boxes are there. It goes 1, 2, 3, 4, 5. Okay, so this shows a force of 5 newtons, and it also shows it toward the right because the arrow is pointing toward the right. Okay, and on your assignment, you're going to be asked to read or draw forces in vectors. Okay, so again, this one is 5 newtons to the right, and that's what you would write down if they ask you how much was this force. You would say 5 newton, capital N for newtons to the right. Okay, then on this part of the assignment, you have to look for the forces on the map. For each numbered force vector, you're going to write down the amount of the force, okay, the number of squares and the direction. So like for number 1, you find number 1, which is right here. Number 1 starts here, and it goes 1, 2, 3, 4. This one's 4 newtons, so you write that down here. And then which direction is it going? Well, it's going from left to right, so it's going right. Okay, your forces could also be up and down. All right, so that's exactly what we did here. We looked at number 1 and we said it was going toward the right. Okay. On this one, this part of your assignment, you're going to be asked to draw a force vector. Okay, and it says draw one for 7 newtons to the right. So what you do is you pick a place to start and you go 7 newtons, 1, 2, 3, 4, 5, 6, 7. And you draw it 7 newtons and you draw it going toward the right. If it said up, you would draw it up. If it said down, you would draw it down. Okay. What was it? Hang on. This figure shows 2 opposite forces. There's a force of 5 newtons to the right, this way, and 7 newtons to the left. You got to subtract them to find the net force, and then 7 minus 5 is 2. So you draw a force vector of 2 newtons, but which way do you draw it? Well, which way has the larger number? Okay, the left has the larger number, so the net force would be a vector that you draw 2 newtons to the left. Okay, in this example, the figure shows 2 forces in the same direction. They're both 5 Newton forces. Okay, so This one is 5, and then this one is 5. And see, they're both going the same direction because you can see the arrows on the vectors. Okay. If they're going the same direction, to find the net force, you have to add them. Okay. So 5 plus 5 is 10. So your net force vector is going to be 10. And since both of these are going to the right, your net force vector has to also go to the right. All right. Then on the last part of your assignment, or your add to find, you have to figure out the net force on something. Okay. So you look on it on your paper for the vectors for number 1. You tell how many forces there are. Then you have the amount of the force, which you have to either add or subtract depending on if they're the same direction or opposite. Then you have to say which direction it's going, and then you have to say the amount of the net force, which is going to be the same as this column right here. So that's real difficult. And this net force will also be the length of the net force vector that you draw. Okay. Then finally, you have to say if there's movement. Okay. How do you decide if it's going to move or not? Well, you have to look at your net force. If it's positive, then it's going to move. If it's 0, it's not moving. So if it's 0, that means the forces would be balanced and in the opposite direction, so that would mean they won't move. So you would say no over here. But if this number is greater than 1, you have to, greater than 0, you have to say yes, there is movement because they're not balanced. And that's it.